Okay, so this is 2.1.10 data representation. So these are some of the important terms from 2.1.9. Binary, computers use binary to store data, which is a base 2 number system that uses bits, ones and zeros, which is different to denary, which we use. And there's also hexadecimal, which is often used to represent very large numbers quickly as like color representation. So these are just some examples of the conversions. So you can do binary to denary, where you look at the numbers and they're all in the powers of 2, and you add together the ones that are indicated by a 1. And then hexadecimal, you can convert into binary and then to decimal. So data representing in a computer, you can use strings, integers, doubles, characters, Boolean, hexadecimal. And what programmers have to take caution with is the size of the different options. As you can see in the picture, a string takes up a lot more space, and sometimes that can be very inefficient. So why use hexadecimal? Hexadecimal uses digits that closely resemble our usual base 10, and they also use the letters A to F. With only 2 hexadecimal digits, you can represent any number from 0 to 225, whereas binary you would need 8 digits. So some applications of hexadecimal: the RGB color model, software errors, MAC addresses, which is a unique identifier for individual electronic devices, a URL, which is a web address that specifies the location of a web resource on a computer network and the mechanism for retrieving it, and also assembly code and machine code. So character sets is a complete set of all the characters on a keyboard. There's ASCII and extended ASCII, which are 7 and 8 bits, and it can represent 128 and 256 different characters. However, the preferred encoding format currently is Unicode, as it uses more bits, which means it can define more than 140,000 characters, which is more accessible for using different languages. And then these are just some examples as colors as hexadecimals.
Right, thank you very much.